We all know that Snowflake allows to define referential integrity, but as soon as it is attached with a table column, it is automatically disabled, and you cannot enable referential integrity except one of them. In this video, we will try to understand what does it mean by that and impact of disable referential integrity in the context of foreign key. We all know that a foreign key is used to define a relationship between two tables. When the primary key of one table, a parent, is added to another table, so-called child table, this becomes the child table's foreign key. So, in this quick and short video, we will cover many informative items and explore foreign key referential integrity behavior in Snowflake. How to create foreign key referential integrity by following different approaches, how to check them using Snowsight as well as using SQL command, and its impact when data is loaded. This is completely hands-on video, so if you want to try along, pause the video, log on to your Snowflake Snowsight web UI instance and start following this tutorial. Welcome back to my channel, Data Engineering Simplified. The hands-on exercise covered in this video can be tried in your free trial account. Create an Enterprise Edition instance on AWS so you can access all the features enabled without any issue. If you have any technical questions, need architectural advice, wants guidance on starting or migrating legacy to Snowflake kind of a data project, do not hesitate to reach out to me on my Instagram account. Many talented Snowflake developers are learning and growing quickly. If you would like to join this exciting journey, be part of my exclusive Facebook group. I am curious to have you on board. You can scan the QR code or find the link in the description section below to join this Facebook group. This is my first worksheet called Constraint using DDL. Let me quickly switch my context. Here it clearly shows that I am using my demo database and public schema, and the role is system admin and warehouse is compute warehouse. Let's check if I have any tables available in this database. I do not have any table. For a simplicity, I am creating a table called department table and I am creating another table called employee table. And we all know what is the relationship between department and employee table. So let me first create the department table. So my department table created successfully. Now next, I am going to create a table called employee table, and employee table is having a primary key called empIdPK. Here the primary key constraint is applied. My first name, last name are not null. I have an email address which is unique and not null. Then I have a department ID FK. This department ID FK is, and for this column, I am creating a referential integrity with foreign key. So if you look into this construct, it says keyword constraint followed by name of the constraint. Here you can specify any name. However, since it is a foreign key, we have given foreign key between employee and department table. Then I am using keyword called foreign key. And which column is a foreign key? So here department ID FK is a foreign key. What kind of reference it has with the department table? So here I am using department table and the column department ID FK. Likewise, it has a self reference which is FK employee manager, and this is my manager ID FK, and the employee is employee ID FK. So many employees will have a manager, and manager also is an employee, and that's why that employee ID will be having a self reference with employee ID. So let me select and create this table. So my employee table is created, and let's quickly run the show tables command. I can see I have a department table, employee table. This is the transient table type. It does not have any data set as of now. So this is a very standard SQL construct in most of the database or data warehouse system allows you to create a constraint with following keywords. Now let's describe the table and see whether I can see this foreign key relationship through this SQL command. So the department table has department ID PK and the department name. Can it take a null value? No. This is my primary key. It's not a unique key. And here it is a unique key, but not a primary key. So these relationships are displayed, and here I can see my comment which is given while creating the table. So when you run describe table, the foreign key referential integrity is not displayed. Now, if I have to check the foreign key referential integrity, can I get it through the getDDL function? Here it shows my department PK. Now let's describe the employee table. So if you look into, this is my two foreign key and this is my primary key. This is a unique key. So if I look into the primary key, this is yes flag. Email address is a unique key, and I do not have any other detail about foreign key referential integrity. So if I run select getDDL statement, highlighted line shows that it is a unique key for email address is defined. Primary key is also defined. It has got two constraints. So the first constraint is on department ID FK with reference to the department table with department ID PK. And the second constraint is named as FK employee manager, having a relationship between manager ID FK and employee ID PK. So this is how you can check whether you have foreign key referential integrity exist between two table or not. Now let's quickly go and do a reverse engineering using our dbeaver community edition, and let's see what happens. So I'm using dbeaver 22.3.3. It is a community edition which is installed in my machine, and this is my demo database. This is my public schema. If I right click on this table, yeah, I have a department table and I have an employee table. And if I look into the foreign key, I have two foreign key available in this. And if you look into this diagram, here I have employee key PK is a primary key, department ID PK is a primary key. Here I have a department ID FK. You can see this relationship is built, and if I highlight this, this relationship is built. So defining a foreign key relationship helps your business analyst team or any other team who is analyzing the structure of your database can understand what is the functional relationship between different entities, and accordingly they can write some kind of a unit testing once data is populated. Now in the next section, we will try to understand how to create referential integrity between two tables using alter statement. This is my second worksheet, constraint using alter statement. So my context is changed. Now I am going to create exactly the same department table, but this time the name of the department table is department underscore 02. It is done. Now I am going to create another table called employee 02, but it does not have any referential integrity created along with the DDL statement. So this is also created. Now before I really create the referential integrity through the alter statement, let's go back to the dbeaver. Now I can see department 02 and employee 02 appeared. And if I click on the employee 02, I have sys constraint, but I do not have a foreign key constraint. Okay. If I right click and view diagram, so if you look into this diagram, these two employees are not showing any relationship. Now let's go and run the alter statement and recreate this diagram. So if you look into the line number 27 onwards, this is how the alter statement looks like, which says alter table employee 02 and add a constraint of named FK employee 02 department 02. This is the pattern I'm following. And the foreign key name is department ID FK, and it is associated with department 02 department ID PK. So the syntax structure looks very similar what we have seen inside the table when we created it. However, here it is added by this additional keyword called alter table followed by table name. Now let me create this. So statement executed successfully. This is the self recursive relationship, and let me quickly show table. Now I have department 02, department employee 02 tables, and this also does not have any data. Looks good. Let's run getDDL on employee 02. I'm able to see my foreign key relationship. Now let's go back to our dbeaver and try to refresh the screen. I can see the relationship between employee 02 and department 02 and with employee 02 with employee 02. Now let me recreate this data model. So I can see whether I add the foreign key referential integrity using DDL statement or whether I do it through the alter statement, in both the cases, it generates the same output. So what we have understood that Snowflake allows you to create foreign key relationship. However, it does not enforce. What does it mean? That when you try to load the data, which we are going to see later part of this video, it does not ensure that those referential integrities are enforced. Okay, and that's why we call it, as soon as you create this foreign key referential integrity, it is disabled automatically and you cannot enable that. Now the next question you will have in your mind, should I create referential integrity by following the approach 1 along with DDL statement, or using approach 2 where we followed the alter statement? My recommendation is to create referential integrity, because if you try to create a referential integrity on a non-primary key, Snowflake will complain. And let's try to simulate that. So let's try to understand what happens if I do not define a primary key. So I am creating a department table called department03. It is created successfully. However, you see I have not used any primary key keyword to define that department ID is a primary key. Likewise, when I am creating another table called employee03, I have not used any unique key or a primary key. Now this is created successfully. Now I'm going to run an alter statement where I'm saying add a constraint like as we have done earlier, and it is going to build a relationship between department ID PK. And in this case, I end with an error saying that primary key or unique key does not exist for the column referenced by the foreign key. If I try to build a recursive relationship, let's see what happens. Here also, it ends with the same error, like primary key and unique key does not exist. What if I try to add those constraints inside my DDL statement? Let's try that out. So I just copied pasted from my approach 1. So this is my department 3, this is my employee 3, and I'm just keeping rest of the information as is. And let me quickly run this. It ends with the same error. So the prerequisite to create a foreign key in Snowflake, that your reference column should be either unique or a primary key in the table definition, else it will end with an error. So we have seen how to check the constraint through the DDL statement. However, that is not a very convenient way. We must have another way to check the foreign key relationship. So this is my another worksheet called check constraint. I change my context. We have seen in our previous video how we can check the primary key in my schema. This is the SQL statement, and let me run it. So it shows all primary key. So we have 4 primary key in 4 different table. Looks good. However, if I try to run a similar command called show foreign keys in schema, let's see what happens. There is no command called show foreign keys. Maybe if I change it to show constraint keys, this also doesn't work. The Snowflake captures all the table constraint in a view called table constraint view in this information schema. And here you can give a constraint type foreign key, and constraint schema is a public, and let's see what does it bring. The first column is your database name, second column is your schema name, and if you look into the table on which I have the foreign key relationship, so I have 2 foreign key on my employee table and I have 2 foreign key on my employee 02 table. So this is how you can capture the foreign keys. The constraint name list the name of the foreign. So by running this SQL statement, you can actually fetch the foreign key constraint in your database. There is another view called referential constraint, and let's run this. Now here also you can understand all the referential constraint, and it specifically talks about your foreign key relationship. So here if you look, the constraint names are this, and this relationship is unique constraint name. So these constraints are automatically created, which is called system constraint. And if I go back to my dbeaver, here you can see this is my constraint on my keys, and these are the relationship. So Snowflake still does not have a view like this, and let's go back to Snowflake data tab to understand how does it look like. So this is my demo database, this is my public schema, and I have these department tables followed by employee tables. Let me quickly click on employees table. So if I click on this table definition, the table definition allows you to see the constraint. So this is another way to check different constraint, which is a system constraint followed by referential integrity constraint. If I go to the column, the column does not show any kind of a system constraint or a referential integrity constraint. Here it can show you the comment which is attached to this column, tag and masking, but it does not show any system constraint or a referential integrity constraint. Now I can also click on this information schema, and this is my view, and I can go to referential constraint, click on a data preview, and I can see all the referential constraint available in this table, which is 4 in my case. And you have another view called table constraint. And here you can see all kind of constraint which is available, all the table inside the schema, which includes your referential constraint as well as system constraint. So the referential constraint is a view which is a subset of a table constraint. Now what happens if I drop my department table? Will the referential integrity be dropped automatically? Let's try that. So this is my department 02 and employee 02. Let me drop this department 02. Now when I drop the department 02, I have two constraints which is called FK employee 02 department 02 and FK employee 02 manager. Technically this constraint should be automatically deleted. Okay. Now let's drop this table. So my table got dropped. Now let's run this referential constraint view. So it has brought only 3 record. In the sense, employee 02 department 02 got dropped automatically. Interesting. And let's check this one. Here also it is reflecting the same. So if you drop a table which is being referred by another table as a child table, then if you drop the parent table, all the child relationship will be deleted automatically. And that makes sense to me. This part of the video will show you how to drop a constraint. And you may ask a question, why should I drop a constraint if it is created successfully? Look, sometimes we have some best practices with respect to naming convention. And in case if we have not followed the naming convention, then I have to drop the constraint and recreate the constraint. Or if I have created a constraint on a wrong column using reference keyword, then I need to drop it and recreate it. So that is the purpose of dropping the constraint. So this is my new worksheet where I am just demonstrating how to drop a constraint. So I'm going to drop a constraint on my employee 02 table. So I created the constraint once again, and let me first show the constraint. So I am running a select statement on my referential constraint view. I have 4 constraints and I want to drop this employee department relationship. So for that, I can run a command called alter table, and this is a DDL statement. And here I will use a keyword called drop constraint and followed by the name of the constraint. And let me do that. I forgot to change the context. So it says statement executed successfully. So I do not have FK underscore employee 02 underscore department 02. Now I can use alter statement and create the same constraint. So this is how we can drop the constraint. So now we have seen how to create the constraint. Now we will see the impact of data loading when we have a referential integrity constraint on our tables. So this is my 5th worksheet called insert data. I change the context. Now this is my standard insert statement on the department table which we have created as a part of approach 1. Now let me insert 3 record called sales, marketing and engineering. I got the 3 record inserted. Now let's run the select statement. We know we can also preview the data from this screen by clicking on the preview, and here the summary of rows will also be visible and the size of the data. Now I'm going to insert employee data, and here I have a record from 1 to 10, and if you see, this is my department ID FK, which is referring 1 followed by 2 and rest of the values are 3. Okay, now let's execute this statement. Total 10 record got inserted. Now let's run the select statement. I can see from 1 to 10, and here I have department 1 followed by 2 and followed by 3. Looks good. And if you look into this, here I have a manager FK. So I have a 3366, and in some places we have a null. Now, if I run this insert statement once again in any traditional database system, this dataset should not be inserted and it should fail with an error. Let's see how Snowflake behaves where we have a primary key as a system constraint. So 3 record got inserted, and if I see department, so I have the duplicate data available, and if I run my I can still see department with unique constraint, department ID PK as a primary key. This is what Snowflake means, that it is allowed, but it is disabled. It means that you can define this system and referential integrities. However, it cannot be enforced, and by default, it is disabled. Now here from line number 43 to line number 46, I am inserting some negative record which is not aligned with my referential integrity, and let's see what happens. So this also executed successfully, and if I run my select star from employee table, I can see this duplicate entries of John and not referring to the right department ID as well as employee ID. Now let me try to insert this null value into the department table where department name should not be null. Let's try that. So it says null result in a nullable column. If I try to do the same thing where my first name is null, so it ends with the same error saying null result in a nullable column. Not null constraint is the only constraint as of now in Snowflake which is enforced and enabled. However, all other constraints, whether it is a system constraint or a referential integrity constraints, are allowed to be defined. However, they are not enforced, means they are by default disabled and you cannot enable them. So these disable referential integrities and system constraint bring some challenges when we are creating and managing our data platform. First, since it is not enforced by the system, you need to make sure that there are some manual enforcement required, which leads to extra development and extra processing power, means extra cost. Increased cost of maintenance. So by chance, if incorrect value get into your system, the cost of maintenance is very high and it will lead to inconsistency. It impacts the performance and storage because you may have to have some intermediate table, or if you get incorrect data, or since primary key constraint and unique key constraints are not enforced, you may end up with a lot of duplicate record and it will increase your storage cost as well as it will impact your performance. So we have understood how to define constraint by following alter approach or directly inside the detail statement. We also understood how to check the table properties when it comes to the referential integrities and the impact of data loading when we have the referential integrities defined. I hope you have enjoyed this quick and short video. There are a couple of more properties with respect to referential integrity which has not been covered in this video. All those properties are at definition level, but they do not enforce anything. Snowflake tables hold many key insights. To become a Snowflake Cloud Data Warehouse Pro, make sure to catch all the videos in this playlist. Thanks for tuning in to this quick tutorial. If you have found it valuable, hit the like button. By doing so, YouTube will serve up more Snowflake content from my channel to help you on your Snowflake learning journey. Happy learning and keep on growing.